please welcome our next speaker, Matt Traxinger, a product development lead. Today, he will be presenting on automated testing. Please stick around after Matt's session for a live Q&A.
So welcome everyone to Automated Testing with Business Central. Thanks everybody for attending DynamicsCon. My name is Matt Traxinger with Archer Point. I very much appreciate you voting for this session and putting it at the top of the list. It's one that I'm pretty passionate about, so I'm looking forward to talking about automated testing with you. Again, my name's Matt Traxinger. If you don't know me from past presentations, I've been in the NAV or Business Central community for about 15 years now. Was a Microsoft MVP once upon a time, but for the last 10 years, I've spent my time with Archer Point focused on development quality and making sure that our 40 or so developers are, building quality solutions for all of our customers. And we recently started an automated testing initiative. So our goal is to have 100% of our AL customers using automated testing. So that's why I wanted to bring this session to you all and hopefully get you all involved in doing it as well. So thank you again for attending. So just a quick agenda so everybody knows what you're getting into here. We're going to talk a little bit about why we care about automated testing in the first place. It's one of those things that has been around for over a decade with NAV, but it hasn't really taken off. So we're going to talk about, why we care and what we're going to do with it. We're going to look at some kind of hard data about automated testing and bust some myths that people might have about whether they should start doing automated testing or not. And then last but not least, we'll get into the actual technical part, which I know is what everybody cares the most about. We'll talk about how you start with automated testing, how you will build your first test and how you'll execute it and things like that. So yeah, let's get into it. First thing I want to talk about is the general principle of software quality, because that's one of the things that automated testing is about. So we care about software quality because improving quality reduces your development costs. And that's kind of the main point of any quality initiative is to reduce those development costs. And we also know that the best way to improve productivity and improve quality is to reduce the time spent reworking code. A lot of estimates put the time spent, redoing code at as much as 50% of the development lifecycle. So we know that the most obvious way to reduce costs is to reduce that work that you shouldn't have had to do in the first place. And it really doesn't matter whether that work or that rework is caused by, development mistakes or issues with the design of the solution. All that matters is that it's work that's being done again that you shouldn't have had to do. So that's the general principle of software quality. And along those same lines, what is the goal of testing? We want to be on the same page as far as why we test in the first place. And that is to maximize error detection as early as possible with the smallest amount of effort, with minimal effort. We want to spend the least amount of time testing that we possibly can. Because if we think about it, testing in theory is something that shouldn't have to happen at all. If we've gathered the requirements correctly, if we've come up with the design the right way, if we've built it the right way, that's all work that has to happen. Doesn't always happen perfectly the first time, we all know that. But in theory, if all of those things go according to plan, you really shouldn't have to test at all. But that doesn't mean we don't test. We still want to do as much testing as we possibly can, but we want to spend the least amount of money doing that. We want to minimize our costs as far as testing goes. We want to find that balance between finding the most defects or finding the most bugs in the solution. We want to do that as fast as possible with the least amount of cost for building that solution. And then the last thing here is, what do we value? We have to value some things as developers. why would we want to pursue automated testing in the first place? And the first thing is fast feedback. We don't want to take, days, if, maybe hours if you're lucky. We don't want to take a long amount of time to find out whether the change that we're making has been successful. We want to find that out as quickly as possible. And then we also want to do that in a repeatable fashion. We want confidence, we want predictability. We want to remove all of the manual tasks that introduce all these kind of strange inconsistencies when we develop. We don't want to depend on somebody always remembering to do a certain type of test or do it a certain way. We want it to be quick, we want it to be repeatable. That way we can get these solutions out the door as quickly as possible with the fewest amount of defects. Hopefully those three things together kind of put things in perspective about why we're pursuing automated testing, what it actually is in terms of the business value that it provides, and then what we value as developers, why we should think it's important as well. So the next section that we'll go on to is about testing myths. So we're gonna look at some hard data and bust some myths that a lot of people have about automated testing. The first one, testing means higher quality. You might be saying, you said testing leads to higher quality in the previous slides. And it does, but it doesn't necessarily mean higher quality in the same vein. It all depends on what characteristics of quality you're trying to maximize. So this first piece of data is from a gentleman named Capers Jones. He does a lot of studies on software quality, software testing. This is a study from 1986. So yes, it is 35 years old at this point, but that doesn't mean that the things that were found in these older studies don't apply to us as well. So the fact of testing is that it does find issues. There's no doubt about that, but it doesn't fix them. So testing by itself doesn't necessarily lead to a higher quality solution. It may prevent bad code from moving into your production database or your live database, but the act of finding a defect doesn't necessarily mean that the overall quality of the solution is better. It might stay the same, but you actually have to go and fix that defect once you find it, and that is what increases the quality. So just don't think that testing by itself is going to lead to a better solution. The earlier in the process you can find those defects, the cheaper it is to fix them, the faster it is to fix them. So it's not about waiting until the end to test after the development is done. If you have a choice, test all the way through the process. The automated testing comes in kind of towards the end. So again, testing finds issues. It's great. We do want to test, but it doesn't fix them. That part still has to be done. The second myth here, more testers means more defects. Again, this one is from the same person, Capers Jones. It's from a 1991 study. Part of this fact may seem obvious, but part of it might not be. So the number of defects found correlates directly with the number of users. So when we talk about testing, it kind of makes sense. The more people you have testing that solution, probably the more defects you're going to find. The more bodies you throw at it, the more bugs you'll find in that solution. That part makes sense. The number of defects found also correlates indirectly with the total number of defects. So how does that part work? If you have more people testing it, you're going to find more defects. But if you have so many defects that the solution isn't really usable, then people stop testing. They stop reporting bugs. And that can give you the false sense of security that you're throwing people at the solution. Everybody's testing. They're not reporting anything. So what I've done must be good. but the reality is it might be bad enough that people just aren't using it and they're not telling you that it's not working. So there is a direct correlation between users and the number of bugs found, but it does, if it's bad enough, they might not be reporting anything. So don't let the fact that you think people are testing or that you're not seeing defects come in, don't let that alone make you think that your solution is ready to go. It's ready to move to production. You have to kind of take it all with a sort of more all-encompassing view, so to speak. So this next slide, this is probably my favorite slide. Some people like to talk about testing in terms of a pyramid, which is the opposite of this. I like to talk about testing in terms of an ice cream cone. So if we think about this, pretty much what everybody does nowadays is manual testing. That's the way we have done it for a long time. You know, as long as I have been working with Business Central, with Nav, as long as I've been in this industry, everybody does manual testing, and that's kind of like the ice cream. Everybody likes ice cream. Everybody likes manual testing. They just kind of go together. But what's really happening here is you start eating that ice cream. You're holding your ice cream cone, and that ice cream tastes good, but it's really dripping down the sides and it's making a mess all over you. And it's not actually giving you what you want or what you need in terms of a quality solution. So everybody likes ice cream, but it's not always the best thing for you. Same thing with manual testing. Everybody likes manual testing, but it's not the best way to test. And it's not the best way to find defects in the solution. It's actually possibly the worst way. It's definitely the most cost inefficient way. And by the time you have people doing manual testing, at that point, it's also takes the most time to fix those defects once they are found. So it's actually probably the worst way to do testing. Doesn't mean that you shouldn't have any manual testing, but it shouldn't make up the bulk of what you're doing. And then just a step below that is the automated GUI tests. So I'm actually purposefully not going to talk about the automated GUI tests that Business Central is capable of doing, because again, they're not very good for you. They take a long time to execute. They can increase your build times. So it kind of goes against the slide about what we value, which was fast feedback. It's not that automated GUI tests aren't, that they don't have their place, but they're not nearly as important as the bottom two, integration tests and unit tests. That's what we're going to focus on. And the way I kind of like to think about these types of tests is, if you ever have a ice cream cone nowadays, a lot of times you have that kind of piece of chocolate at the bottom of the cone that prevents the ice cream from dripping out the bottom. That's kind of the mess that you don't see happening. And that piece of chocolate at the bottom of the ice cream cone is what stops that mess from happening. When you're doing manual tests, you see that dripping down the side. You can kind of take care of that. But when you have that chocolate stopper in the bottom of the cone, it's kind of like a backstop. It prevents the mess that you don't see happening. And that's kind of why I like integration tests and unit tests more so than the automated GUI tests. That might seem like a weird analogy to everybody, but I actually really like the ice cream cone analogy. I hope it makes sense to everybody. So I would also be remiss if I didn't talk about test-driven development at all. So this is another study, slightly more recent, from 2003. It's an initial investigation of test-driven development. If you're not familiar with test-driven development, it's essentially, if I were to, condense it, really over-condense it down into a single sentence and relate it to what we're about to talk about. It's exactly what we're going to talk about with automated testing, but you move it earlier on in the process. So you decide what your tests are going to be before the development actually even begins. And if you think about it, that makes sense, because if you don't know what the user is actually expecting, in a very specific way, if you don't know what they're expecting out of the system, you don't necessarily know if you're building the right thing. If you don't know exactly how the user is going to test, then you don't know if you're testing the right way and delivering the correct thing. And then once you find out that you haven't, that's exactly what causes that rework to begin with. It causes you have to change your code, redevelop your code, just debug issues, and that's the time that you shouldn't have to spend at all. So this study, it found a lot of things with test-driven development. It was a small study, but 88% of developers thought that the requirements that they got that they made more sense, that they were easier to understand. 79% thought it promoted a simpler design, and that's kind of, simpler design is a cascading benefit. So as you do more and more development, in the future with that solution, it means it's simpler and easier to modify going forward. 96% reduced debugging effort. So they say as much as, again, 50% of the rework time is debugging and refactoring code. So a 96% reduction in debugging time is huge when it comes to cost and speed of developing a solution. 78% productivity improvement. The next one I think is the most important. 92% said that their code quality was higher. So the developer actually, thought that what they were delivering, they had more confidence in what they were delivering, that it was more likely to meet the customer need, that it was more likely to be easier to understand by future developers. The downside, well, 56% thought it was hard to get into that mindset of doing test-driven development. So this stuff isn't easy, but it has a huge benefit if you can kind of shift your mindset to start doing things this way. So hopefully, these facts, these numbers kind of give you that push to get into automated testing. Again, it's been around for, I think, about 12 years now. It's been around even from the Cal days. So I'm hoping these kind of give you that nudge to start using it. So if you have been kind of pushed off the automated testing cliff, so to speak, you might say, where do I start? It just, that's always been what people have said. It just seems like there's so much there. It's going to take so long to create tests that are useful. How do you actually begin doing this? So you shouldn't aim for 100% code coverage. That's always kind of been this thing out there, that you have to get to 100% code coverage to make sure that your automated testing is useful, and that's really not the case. The vast majority of your code is probably already there. It's probably working the way it is intended to, and it's probably never going to change. So if that's the case, you really don't need to go and create tests for that. It's perfectly fine if you want to, but in my opinion, it's not really necessary. So if we can kind of use our old fallback of 80-20, 80% of defects occur in 20% of the code. You want to figure out what 20% of the code has those defects in it, and you probably already know it. Every solution has those big ugly code units that are hundreds or thousands of lines long that do way too much. But those are probably the objects that you want to start with, that you want to build tests for. And then hopefully everybody's using some type of source control solution, so you have a history of changes that you have made to certain objects. Typically 80% of the changes occur to 20% of the code. So you're repeatedly modifying the same 20% of the objects in your solution. So there are commands with Git that you can use to pull how often objects are modified. You can pull that information from source control. So just take your top 20% most often modified objects and start there. Start building your tests on those functions. And that will give you the most bang for your buck in terms of building tests that actually provide value to the solution. So let's get started with the actual development of automated testing. We're going to focus on the AL side, which, the most recent version of how you do automated testing. That's what the slides will talk about. But I will also try to mention how you would do this with Cal if you're still on a Cal version, or how you would also do it with some of the earlier versions of AL. In the most recent version, there is a file called settings.json, and we use this file to tell us how to install the components that are necessary to do automated testing. So by default, the database that you get, it does not include any of the things that are necessary to build automated tests or execute automated tests or really do anything with them. So there are two components that you have to install, which are the test libraries and the test framework. So the test libraries, though, that is a collection of code that does a lot of common things in Business Central, and we'll talk about libraries more here in a little bit. The test framework, those are the tools that you need to actually execute the tests. So with the libraries, those help you write the tests. You don't necessarily have to have them, but they do make it easier to write the tests. And then the framework is what allows you to execute those tests. And then the third option here is test folders. That kind of tells Business Central where your tests are located in your solution. So with the old Cal version of testing, you had to import those from the installation media. There were 3 FOB files. If you downloaded the product DVD or the installation media, there's a folder called Test Toolkit, and there are several FOB files in there that you have to import into Object Designer. And those contain the test libraries and the test framework, and those will allow you to do automated testing with Cal. There is no test folders in that case, because all of the testing objects just live within the same they live in the same place as all the other nav code, and in the same place as all the other Cal code. If you happen to be on a version of Business Central that is in between Cal and the latest version, there wasn't a settings.json file to import these things. There was a PowerShell commandlet that was import your test toolkit, and that would import the test libraries and the test framework into your development container. So 3 different ways to do this depending on what version of Business Central you're on. This is the way to do it with the most current version of Business Central. So the next part is you have to actually install those things. That settings file just told PowerShell that it should install them when we go to do it. So we have the run AL pipeline command, and this is a condensed version of that. We're only showing the options here that relate to automated testing. We're not showing any of the other options for creating that Docker container to do your local development. But each of these maps to a setting that you found in that previous file. So the $test folders, that maps to the test folder where your AL files are going to go. The install test framework, that was set to true, so that means we're going to install the test framework when we create the Docker container. Same thing with the test libraries. Again, you don't have run AL pipeline in that middle version of Business Central, so you would run that PowerShell import test toolkit to get these into your Docker container to do the automated testing with that. So next is the actual code to do the automated testing. So just like you have an app folder in VS Code that contains your solution, it contains all your AL customizations or your ISV solution or whatever it is you're developing to sit on top of Business Central. You also have a test folder, and that's what that option from the settings file points to. And that test folder, it's just a separate application. It's just a separate extension for Business Central. It works exactly the same way. It has AL files in it. It has code units. Typically, it only has code units in it, but it could have other things. And it all sits in the same workspace as your initial solution. So your app and your test work together. They're exactly the same for the most part. They're just AL files that come together to form an extension. They get compiled into two completely separate extensions. The difference is that the automated testing project, it has a lot of other dependencies. So your main customization, that probably only has a dependency on the base Business Central application. Your testing extension is going to have dependencies on all of the things that you see here. So the test libraries, the testing toolkit to actually execute those, and anything that you basically installed with that PowerShell command that you used in the settings file. Those will essentially become a dependency for your automated tests. So you certainly have to have the base application. There's an app file here for assert, which we'll talk about. The application test library, which contains all the libraries for, sales and purchasing and inventory, warehousing, all those things to make your life easier when you create your own tests. Yeah, we'll get into all of those here shortly, but though you have all of those dependencies and they are necessary for you to actually run your automated tests. The other thing that it is most likely dependent on is your main solution. So the code in that app folder, that's also in your development workspace. So you need to also have a dependency on that, because most likely you're not just writing additional tests for base Business Central, you're writing tests for your customizations. And if you don't have that dependency in your test application, then it doesn't know what any of those customizations are. So you can't write code on top of them. So just like you have to have a dependency to reference base Business Central, you have to have a dependency for it to know what a customer is or an item is. For example, you have to have a dependency on your solution so that it knows how to execute your custom code. So we'll start here with a test code unit. All of the testing, all of the automated tests are written as a test code unit. They can, in theory, have any object ID you want. Again, between, just like a customization, between 50,000 and 99,999. You can name them however you want, because at the end of the day, it's a code unit object, just like any other code unit object. Still has the same triggers. You can still put procedures in it. The only difference is that there is a property of a code unit that you can set. It's called subtype, and you need to set that to be equal to test. That's what tells Business Central that this is an automated testing code unit that has functions inside of it that will need to execute when you run those automated tests. So the only difference is you set the subtype equal to test. Then when you actually write your test function, your test procedure, you have to also put a qualifier on that says test. So you still write your functions the same as any other functions. And you put in the square brackets right above it, you put the word test, and that's what tells Business Central that this actual function is an automated test. Because remember, this is just a code unit, so that means you can put other non-test related functions in this code unit as well. Anything you can do with a regular code unit, you can do with an automated testing code unit. So just create your function, create your procedure, tag it with test. So what goes into that testing code unit? There are 4 parts to a good automated test. So the first part is what we call the given. So given some data that is required to actually execute this test. So you have to kind of find a balance here with how much you specify in the given. You're typically going to be executing your automated test against a Cronus database. So how much data do you actually need to specify for the given? You know, how far do you go with that? Do you say every little field in every setup table that you need? Probably not. You have to make some baseline assumption about how the system is set up. Otherwise, your tests would it would be too difficult to comprehend, and it would take too long to actually write them. So you have to assume some kind of baseline and say, given this, the given in my test is I need a customer that's been set up, or I need a sales order that has a warehouse shipment attached to it, things like that. If you need to deviate from what kind of comes in a Cronus database, you could say, if it's really important to the test, you can say, I need sales and receivables set up this field to be equal to this value. But you don't want to put too much in the given. It's the minimum viable amount of data you need to execute a test, if that makes any sense. Given some data that you have that's required to run the test, when something happens. So when this thing happens in Business Central, your sales order is released, an item is inserted. It could be anything you want, but it's when some type of event happens, and that's not necessarily to be confused with an event subscription or an event publisher or anything like that. It's not the same. It's just when this thing in the system happens, and again, it can be any action that you need to test. So given this data, when this thing happens, then we test the data. A lot of people get confused with the then, especially if you're doing test-driven development and writing tests ahead of time. They think it's given this data, when something happens, then I do this thing. And that's not the case. The I do this thing is part of the when part of your test. That's what you're actually testing. The then, you're just verifying that the data that got produced from the when is correct. You're not doing anything else. All of the actions that happen need to occur inside of the when part of the test. Given this data, when this thing happens, then I look at my data to make sure it's correct. And assuming it's correct, the last part of a test, and this is an optional part, is you clean up the data that was created due to this test. depending on how you've structured your testing code unit, usually that data is going to be cleaned up for you automatically. But if you have tests that produce data, that commit data, um, sometimes you may want to make sure that data doesn't necessarily influence any additional tests that you're going to execute. So I personally like to leave the database as close to the way as it was when I found it, as close to the way as it was when I started executing that test. So if my given was that I created a customer, then in my cleanup, I'll typically delete that customer when I'm done. Again, not always required, but especially if you're dealing with processes that run on subsets of documents or things like that, it can be very easy to create data in one test that will influence the results of another test. And so I prefer to clean up or delete any data that was generated as a part of this test. So let's look at a specific example. So this is an actual test that I have written for a customer that I'm working with. Essentially, they want to make sure that Business Central doesn't tell them to ship an order on a day that no one is scheduled to work. They have custom order promising logic and capable to promise logic that they want to make sure that they don't ship out an order like on a weekend or on a holiday, for example. So given this data that I need to test with, so there's a concept in Nav called a base calendar. We're going to insert an entry into that table, and we're going to set that as a non-working day. So in this case, we're going to set April 1st of 2021 as a non-working day for the company. And then the next part is when this happens. So when the first working day is calculated. So if we were to set the shipping date to April 1st of 2021, we would actually want to back that date up to the day before, March 31st of 2021, because that is a day that everyone is working. So we have a custom function here that I won't necessarily show the code behind, but it's a code unit called first working day, and it takes in a date value and determines what the first working day is before that date. So if April 1st was a working day, it would just return that value. But because it's not, it's going to back up and day by day until it finds a day that it can actually ship on. We are going to calculate that date and store it so that we can test it later. So next is the then. So given my base calendar change, when I calculate that date, then I expect the data to look like this. So the way that we test data with an automated test, it's called an assert. So part of the dependencies for automated testing that you saw in the AL packages is the assert code unit that gets imported when you install the test toolkit. You can go look at all of the functions in there. We create a variable for assert. Usually that's a global variable in your test code unit. And we want to make sure that these two values are equal to each other. So that this is not too dissimilar from a test field that you might be used to using. So we say, is my calculated date equal to the date that I expected? So in this case, I've got a hard-coded date that I expected of March 31st. And I want to make sure that the date I calculated in the previous step is equal to that. And if they are equal, code goes on like nothing happened. But if they are not equal to each other, then then I will get the incorrect date message that I've entered here. That will show up as how my test failed. So there are a bunch of different functions or procedures within the assert code unit. There's assert are equal, assert are not equal, assert are nearly equal. There's I think there's like 15 or 20 different functions in that code unit that you can use to test with. So sometimes it's necessary to test if things are almost equal, and so that's when you would use the are nearly equal. Sometimes you want to test if they're not the same. So I would encourage everybody to go check out that code unit. It's a good way to kind of introduce yourself to what can be done with the automated testing. But so we have our given, our when, our then, and the next is the cleanup. Clean up my mess when I'm done. So in my given, I inserted that base calendar change. Now I'm going to delete that, and I have left my test database exactly the same as when my test function started. So the given, the when, the then, it all comes together to form this test. So your given is typically going to be the biggest section of your test. That's where you're setting up all of the data that you need. Your when is typically going to be a one line one line of code that executes a very specific function, a very specific action. Then you typically want to test as few things as possible. There's kind of a debate about that. Do you have a bunch of small a bunch of small individual tests that test very specific things, or do you have fewer larger automated tests that test a lot of things? So this would be an example of a test that tests one very specific thing, but you might decide to have a test that posts an entire sales order and tests a bunch of things at the end of that. Some people like to do it that way. I guess kind of depends on what you're trying to accomplish, what kind of quality metrics you're trying to achieve there. But this is an example of a smaller one. But then again, I'll clean up that data when I'm done. So this is what that automated test looks like when you kind of bring it all together. So I mentioned before, we'll talk about library functions. Those are functions that have commonly used functions that you can use. Create a sales order, create a base calendar entry. You might want to do that. This is what that test might look like with when you use those library functions. So instead of having everything in one function, it's kind of split out. You can also test for failures. If you want to use an assert error, that's when you might expect something to fail. You don't always have to test for things that you expect to be successful. And then you can also handle dialogues. If any message boxes or confirmation boxes that pop up, you want to make sure to handle those as well. And you do that by adding a handler function, just like you add that test tag right before your function. And then you have to have those procedures in your code unit as well. But where this all comes together is the actual test tool where you can run your tests. So if you search in Business Central for the AL test tool, you'll see a screen like this. You pull in your test code units using the get test code units action on the top there. You'll see them execute one by one as you go through them, with a dialog box similar to what you see when you're posting a sales order. And then you'll see a list of failures and successes in that same page. Where this really comes together is when you put it into your build, when you check in your code to source control, and all of these automated tests will execute every time you need to publish an app. You get to see your full test history of those tests. Here's an example of where I messed up one day, and I wouldn't have thought that I was going to break something, but I broke a whole lot of things, and I needed to fix that. And automated testing saved the day there. So if you want to learn more about automated testing, feel free to check out these references, check out these studies. But beyond that, I'm looking forward to answering all of your questions that you've been asking in the chat box during this session. So thank you for all attending DynamicsCon. Well, thanks everybody for attending. I'm here to answer any questions that you might have on automated testing. I'll do my best to navigate the chat window, and if anybody wants to come off mute and ask, feel free to do that as well. I did see a question there at the end about convincing customers to pay for the automated testing, and that is something I hear a lot. My counter to that is that you're not paying anything extra for your partner to do that. It's really just shifting the time that you would normally do, like having a functional consultant do the testing. You're just shifting a lot of that time to the development part of the life cycle. So it's not that a functional consultant might still not take a look at the code or take a look at the functionality to make sure it works, but they're just doing that high level testing at that point. They don't have to go in depth because that's all been laid out ahead of time, and it's already been confirmed that it works by the developer because we knew the tests ahead of time. So it wasn't even handed off to the testing phase until that worked. So it's not spending extra time, it's just spending time on that instead of something else. So let's see here. Are there any planned upcoming changes to testing in the future, or has it found its form? I'm not sure if there are any major changes planned. One thing that I hope they put back in is that they had with the Cal automated testing was the ability to only execute tests for the objects that were modified in that specific code check-in. So instead of having to execute every automated test every time, it was smart enough to know what objects had changed and only execute the necessary tests. So I hope that's one thing that they bring back. There's a question, are there parameters to replicate load with multiple users, hundreds of sales orders entered, for example? So there's a newer tool called the Performance Toolkit. It's a lot like the Test Toolkit, and it's built actually on top of the Testing Toolkit, but you can use that Performance Toolkit to simulate those types of things, and that would probably be a topic for a whole different session. So would you say with 1 month into AL, it's a good way to start with test-driven development as soon as possible? I don't know that it matters how long you've been doing AL, whether it's you're just starting or 1 month into it or 6 months into it. I think you should start it as soon as possible. It's just going to make your life easier, in my opinion. And especially if you're on a SaaS environment doing the automated testing, it's hard to imagine a way that you know that you can successfully upgrade without having that automated testing in place. So I say the sooner you do it, the better. So are there any other questions that people would like to ask in the chat window? I'm excited that so many people attended the session on automated testing. I think it's finally sort of coming into its own and people are starting to adopt it. It's taken a long time, but so here's another question. How I answered how I would start, but how would I continue? So should new implementations follow this 20%, or should it go to 100% code coverage? So, I mean, I think it goes back to what you want to measure and what's important to you and your company in terms of quality. I don't necessarily think that 100% code coverage is, a realistic or achievable goal for a lot of people or a lot of companies. And you have to ask yourself, if you've written a function that's probably not ever going to change, do you need to test it every time you check your code in? I would probably say no to that. It just ends up adding time to your build. It adds time to create the test, to maintain the test. If it's something that you absolutely know is not going to change, yeah, I don't think you need to write tests for it. But just keeping on top of what changes you've made, how important are those changes to the business to continue to make sure that they continue to work. Those are the things that I would continue to focus my testing on. So any new extension you create, you should have tests. Yeah, totally agree with that. Is testing set up and run in each extension? So it certainly can be and should be. The way we set up our projects in Azure DevOps is that we just have a workspace. We have a folder or an app for the main customizations, and we have a folder for the tests, and those work together. But I definitely think you should have at least some testing with every app that you create and that you install. So does anyone else have any questions? Oh, sorry, I think I might have skipped one. How much time do you spend on developing test code units compared to the functional time? So I think at the beginning, I spent a lot more time. So I would wager probably half of my time was spent on the functional, the actual code, and the other half on writing the tests. But as you get used to that time you spend writing on tests goes down significantly, probably down to 20% or less of your total time. And really that time is just going to replace the time spent by someone else doing manual testing. Benny said that they spend more time at the beginning, especially, which definitely could be true. So I've seen some repos removing those dependencies and using assert error instead of assert equals. What's the matter with this? You can do it both ways. A test is a test, whether you test whether something is equal to, or you assert that something is not equal, or that assert fails. I don't know that I would do an assert error on an assert statement, but you certainly could do it that way. I think it's a lot easier to just do assert not equal. Are there any third-party BC extensions for automated testing? I don't know that I have seen any out there. As we move into this kind of environment where we have a lot of tools that are available to us that are not Business Central specific, I think we'll probably end up finding a lot of things, such as the ability to record a test by just performing the action in the system. I think we'll start to see things like that, but it won't surprise me if the tools that we see come out of this are not specific to Business Central at all. So let's see here. If you want to run tests on a local installation without a container, so without using the run AL pipeline, what do you need to start creating tests? So really all you need to do is get those Test Toolkit objects installed. And then you'll have access to all of the pages and things that you can use to manually run those tests. You don't have to use the pipeline or anything like that to do it. You can still do all of this manually if you want to. But I will say it is a lot easier to do it with the containers. So are there any other questions out there? If not, I see the next session is about Postman and APIs made easy. So I think that's a good one to go to if you're definitely doing any integrations with Business Central. Postman has become a part of my toolkit that I use almost every day. So I definitely encourage people to attend that if you're planning to attend another session. But with that, thanks everybody for attending and learning more about automated testing. I hope you can take it and use some of this in your own projects, and all it can do is lead to better quality solutions. So thanks again, everybody. Have a wonderful rest of the day.